Alright, so this is from our book. It's called Java Programming. So, alright, with the help of heaven, we will be able to finish it. Alright, basic computer concepts. So today we have to do 1 to 1 to 3.3, 1.1 to 1.3, and this is our 1.1. Okay, computers are pervasive in our daily lives, and thanks to the internet, they give us access to nearly limitless information. Some of this information is essential news, like the headlines of your favorite news web. Excuse me. Like the headlines of your favorite news website. Computers let us share photos with our families and map directions to the nearest pizza place for dinner. Lots of real-world problems are being solved by computers, some of which don't much resemble the ones on your desk or lap. Computers allow us to sequence the human genome and search for DNA patterns with it. Computers in recently manufactured cars monitor each vehicle status in motion, and computers are helping some cars to drive themselves. Digital music players and mobile devices such as Apple's iPhone actually have computers inside their small casing. Even the Roomba vacuum cleaner robot houses a computer with complex instructions about how to dodge furniture while cleaning your floors. But what makes a computer? Is it a calculator? Is a calculator a computer? Is a human being with paper and pencil a computer? The next several sections attempt to address this question while introducing some basic terminology that will help prepare you to study programming. Why programming? At most universities, the first course in computer science is a programming course. Many computer scientists are bothered by this because it leaves people with the impression that computer science is programming. While it is true that many trained computer scientists spend time programming, there is a lot more to the discipline. So why do we study programming first? A Stanford computer scientist named Don Knuth answers this question by saying that the common thread for most computer scientists is that we all in some way work with algorithms. Algorithm, a step-by-step description of how to accomplish a task. Knuth is an expert in algorithms, so he is naturally biased towards thinking of them as the center of computer science. Still, he claims that what is most important is not the algorithms themselves, but rather the thought process that computer scientists employ to develop them. According to Knuth, it has often been said that a person does not really understand something until teaching it to someone else. Actually, a person does not really understand something until after teaching it to a computer, i.e. expressing it as an algorithm. Knuth. Selected papers on computer science. Knuth Don, selected paper on computer science, Stanford, California, Center for Study of Language and Information. Knuth is describing a thought process that is common to most computer science, which he refers to algorithmic thinking. We study programming not because it is the most important aspect of computer science, but because it is the best way to explain a computer but because it's the best way to explain the approach that computer scientists take to solving problems. The concept of algorithms is helpful in understanding what a computer is and what computer science is all about. A major dictionary defines the word computer as one that computes. Using that definition, all sorts of devices qualify as computers. The concept of algorithms is helpful in understanding what a computer is and what computer science is all about. A major dictionary defines the word computer as one that computes. Using that definition, all sorts of devices qualify as computers, including calculators. Also, definitions qualify as computers, including calculators, GPS, navigation systems, and children's toys. Excuse me, like the Furby. Prior to the invention of electronic computers, it was common to refer to humans as computers. The 19th century mathematician Charles Peirce, for example, was originally hired to work for the U.S. government as an assistant computer because his job involved performing mathematical computations. In a broad sense, then, the word computer can be applied to many devices. But when computer scientists refer to a computer, we're usually thinking of a universal computation device that can be programmed to execute any algorithm. Computer science, then, is the study of computational devices and the study of computation itself, including algorithms. Algorithms are expressed as computer programs, and that is what this book is all about. But before we look at how to program, it will be useful to review some basic concepts about computers, hardware and software. A computer is a machine that manipulates data and executes lists of instructions known as programs. A program, a list of instructions to be carried out by a computer. One key feature that differentiates a computer from a simpler machine like a calculator is its versatility. The same computer can perform many different tasks: playing games, computing income taxes, connecting to other companies around the world, depending on what program it is running at a given moment. A computer can run not only programs that exist on it currently, but also new programs that haven't been written yet. The physical components that make up a computer are collectively called hardware. One of the most important pieces of hardware is the central processing unit, or CPU. The CPU is the brain of the computer. It is what executes the instructions. Also important is the computer's memory, often called random access memory, or RAM, because the computer can access any part of that memory at all times. The computer uses its memory to store programs that are being executed along with their data. RAM is limited in size and does not retain its contents when the computer is turned off. Therefore, computers generally also use hard disks as a larger permanent storage area. Computer programs are collectively called software. The primary piece of software running on a computer is its operating system. An operating system provides an environment in which many programs may be run at the same time. It also provides a bridge between those programs, the hardware, and the user, the person using the computer. The programs that run inside the operating system are often called applications. When the user selects a program for the operating system to run, example that by double-clicking the program icon on the desktop, several things happen. The instructions for that program are loaded into the computer's memory from the disk. the operating system allocates memory for that program to use, and the instructions to run the program are fed from memory to the CPU and executed sequentially. Alright, so with the help of Evan, we will be back in the next video with the next pieces of content. Other than that, good job for everybody who's been following along and writing down notes. Other than that, we'll see you guys in the next couple of videos. Alright.